Speaking of reliability, a podcast with good friends talking with you about reliability engineering topics. Welcome to Speaking of Reliability. This is Fred Schenkelberg.
And this is Chris Jackson. And we were just talking about a scenario a client of mine's dealing with where they had issues with the component and they are feverishly trying to find a way of selecting a supplier for the component which doesn't have quality control issues.
Well, I mean, it was one of these discussions where, hey, Zach, Chris, I got to hit record. Let's stop talking about it. Hit record. So a little bit of background is that it was a component into a larger system, and it is doing like a 1% defect rate. So my little stats brain went, okay, you got a 1% defect rate. If you know the failure mechanism that you're looking for, you might be able to create a way to see if that condition exists. I know in electronics, we used to do dummy test boards, basically, and then we would cross-section the solder joints and look at the metal bonding that occurred, the different types of structures that were in the solder joint. If it was done correctly, it would look like this. If it was not done correctly, it would look different. But we knew exactly what we were looking for. And we would run these tests and we could tell real quick whether somebody was screwing that up or not. But that's when I said, oh, we got to hit record, because you alluded to this company that's buying these components doesn't really know what in detail they're looking for. They just want to know they have good ones, kind of not well defined.
And that's the problem, isn't it? It's look, you could sort of do a fault tree, not in terms of what way things fail, but your options.
Oh, sure. You and I could come up with a couple hundred ways something could fail pretty quickly.
Right.
That doesn't help.
But what options do we have on the table? I mean, one of the options is you establish those wonderfully harmonious, transparent, synergistic relationships with your suppliers, where you learn what fails or what the issues are with the components. You send the information back to a supplier, and the supplier says, "Thank you very much. We'll put that into our next batch," and you have this wonderfully symbiotic relationship where everyone wins.
Right. Yeah, that happens all the time.
Well, I mean, it obviously doesn't happen all the time, but
No.
But I think when we explain these wonderful scenarios to people, it's like they're missing a part of their brain where they believe it's a thing. But it is a thing, as you know.
Yep.
What else? So that's one option. The other option is
make them yourself. Don't buy the component; just do it yourself.
Right. So that's option number 2. Make it yourself with all this wonderful expertise you can then generate, and this wonderful focus on reliability.
One component of one part of your system. Yeah.
So that's option number 2. What's option number 3? Option number 3 would be actually doing something along the lines of a FMEA fault tree analysis, whatever you want to call it, where you get a good understanding of how that component fails and then give very strict guidance to your suppliers, your market. Say, hey, we need you to give me components which are robust at this corner and solid here and shot peened over there, because these are the weak points of this component you provide us. We've done some of the hard work for you. Make sure you do this.
Yeah, well, I'd say it's, if they're experiencing failures now, do they have reasonable failure analysis of the failed components, or is it just they know it broke?
At this stage, they know it broke. But that's the next part or I suppose the next option would be is that if you have a good, up to option number 4, if you understand through failure analysis or what have you, going back to your FMEA or fault tree, what those quality control issues are going to look like, can you establish some sort of inspection regime, which is similar to what you were describing, Fred, where you essentially know what a good version looks like.
Well, I mean, the issue is in the way you described it briefly, is that, they have this component and they could get it from a couple different suppliers. Mm-hmm. They're not exactly sure if it's a single type of failure or phenomena that occurs that causes the defect that causes the failures they're seeing. I mean, that's just not clear. It's possible that it could be that way. But if they go to a different supplier, and I know this from experience, is you just basically trade one set of potential failure mechanisms for a different set. And I think the other piece of information we had off mic was the industry isn't known as, what was the phrase used, as the powerhouse of SPC and process quality control that,
Right.
Toyota is or other organizations are, kind of thing. So it was like, switching to a different supplier and running the test that finds the faults that you know about may not help you at all, because it's just going to be very likely going to be just a different set of problems that may or may not be found in a test.
What are our options up to now? So we've got either symbiotic relationship, number one. Number two, I need to keep track of this. Listeners will be able to work out if I can remember what I was just saying. Option number,
make it yourself was option two, but there's do the root cause, FMEA, fault tree, sort it out. What could be it? What's most likely? Do some experiments, feed it into the system so they fix that. Or I think we're up to 4 was then test it. Create a test, inspection, testing, something like that.
There's a couple others though.
Uh-oh.
Well, you know this, and number 5 is if it's quality control issues, you can do burn-in, where essentially you simulate not just real world conditions, perhaps robust real world conditions, where you get the component, put it on a test bed, and test it for a certain period of time or usage, such that you would reasonably expect any quality control issues to manifest themselves through the small fraction of components which have them.
Right.
And those get simply removed from your population, and the things that are still working at the end of your burn-in testing, you then install in your system.
Yeah. See, I wouldn't advocate burn-in. I'd say HAS, highly accelerated stress screening, which is a variant of the same thing in my mind. But the issue is that if you don't know what your screen, and this only comes from experience, that I saw these people that said, "Oh, we have this problem with," it was some material or component that had a moment arm in it, and so with vibration, that arm that was suspending the active element of this piece of this electronics component would crack and fall off, and it was due to thermal cycling. But it would take very, very long time. It was thermal cycling or vibration. And if it got just the right frequency of vibration, which happened to be generated by a hard drive sitting next to it, it would fail pretty quick. And so they said, we have to do burn-in because we don't know which of our stock is prone to this issue. They sorted out semi-symbiotically that it was a manufacturing issue. And they're wondering why they were still having the problem. And you know where this story is going, is they had a burn-in chamber. So they put all the components in an oven in high temperature for 2 days and figured that was burning it in, and then it would be fine if nothing failed. And so that would be just fine. And I'm like, okay, you need to think about what you just told me in the last 4 sentences. You have a vibration-induced failure and you put it in a high temperature, steady oven. Okay.
Maybe they put it in the oven because they took the phrase burn-in way too seriously.
Yeah, no, that was what somebody said. We used to do burn-in on ICs, and we have an oven and chamber. It's available. Let's burn it in.
Oh, my God.
Yeah. No.
Oh, my God. All right. Yep. So that just happened. So that's option number 5. Let's call it
with a caution.
Yeah. So some people call it burn-in. You could argue HAS, highly accelerated stress screening, is where burning can include non-accelerated stresses. I would argue. HAS implicitly implies that you use obviously much higher stresses.
Well, it doesn't. Not always. No, it's just different, and it's a different algorithm to get there. In my mind, anyway. There's two similar, but I think the idea is that you still have to have that understanding of what you're looking for, such that you expose the ones that have the weakness. Now, I actually if we're doing brainstorming here, we could maybe not number this one, but you could also do destructive testing, take them all apart to see which ones fail quickly. Do a material, do a cross section and check the materials to see if the grain structure is prone to fatigue or something like that. And in electronics, you really can't do that.
No.
Cutting open your IC to see if it's bonded correctly pretty much destroys the IC, and it's hard to sell those.
As a rule, yeah, because you actually need to unbond them to see if they've been bonded.
That's right, pretty much. Pull test on your solder joints is usually not a good way to screen your product, because 100% destructive testing doesn't leave a lot to ship.
Right, and then so that's option number 5, some sort of screening test, and then you talked about an unnumbered option where you actually do destructive testing or failure analysis of defect analysis, maybe is a term you could use. But even that, you're just, all you're trying to do is still understand how the damn thing is going to fail, which is, I think, better than other options we've talked about. And of course, I think option number 6 would be to design a system which is robust, so that if you have a component which has certain failure modes and failure mechanisms, or a fraction of them will, what can your system do to mitigate that through perhaps early warning or reducing the stresses? But again, you still need to know how those problematic components are going to ruin the day of your system. So that's number 6. And I think we've exhausted all the really ones that you and I prefer to do. And option number 7 is statistical based testing.
Oh, what are they called? Do a bogey test. Just do 22 samples.
Yeah.
And you'll have 90% confidence that it's 90% reliable. But they were trying to detect whether it was a 1%. So now you need hundreds of samples.
Right.
And a test that actually is meaningful.
So one of the questions was, what sample size do we need to be able to see if a batch has quality control issues? And again, you pick a number. Say it's 1%. Say it's 3%. Whatever. Say 3%. 3% is actually easy to detect. So let's run with that.
Okay.
But then you'd still need to you'd expect that for every roughly 33 samples, one of them would be defective in those batches that you're trying to detect has a quality control issue.
Right.
And if that's the case, then as they say, you need a minimum of 3 data points, 3 observable data points. So you need to have 3 quality control issue components detected during tests. So all of a sudden you're up to 100 total components being tested to see if there's 3% of them defective, yes or no. And that could be your entire batch done.
Yep.
So,
and that assumes that you actually know what you're testing for, which was hard as a bunch of the earlier ones to start with. Let's just get 20 samples and test them. All right. How do you want to test them?
Right. So what are you testing for? I mean, if again, you still need to know the failure mechanisms, even for statistical testing, the brute force testing, because how do you uncover these things? It almost lends itself straight away to a screening test, where if you're going to do the test anyway to see if they have any quality control issues, well, the ones that pass the test don't. So use them and just discard those 3% or however many percentage of components have those quality control issues, and that could be embedded back into a feedback mechanism to your suppliers, and off you go.
Well, it sounds like it wasn't a software system, because otherwise they would have had that option. Maybe option 12 here is, we can fix it in software. It was a mechanical system, I take it.
It is mechanical, yeah. So,
but yeah, you can still fix that in software. Just don't sell it to the people that break it.
But I think the underlying issue here is that it's still an organization that, and I think this is an endemic and emblematic of a lot of organizations out there who want to deal with things at a contractual or transactional perspective. So I only want to deal with reliability at the point of sale. I want to be able to have some absolute yes, no, is this good? Is this batch good? Yes, no process at the point of sale, and then not have to worry about it thereafter.
We get that all the time, though. I remember opening boxes and seeing people opening stuff at factories, and then the top of the sheet has a certified results of various processes that that supplier was doing, and maybe even had a X bar R chart or something similar to that in the box with the batch.
Right.
And it became apparent very quickly that their photocopier needed toner because every box, I looked at where they were storing these things in the incoming part, and it was basically the exact same stuff with a different date and shipping number on it. But it was the
Yep.
exact same chart from 4 years ago that they just kept
Right.
photocopying. So it's like, didn't anybody? Oh, my job is just to see if it's there or not. Not to, I don't know what it is, and they would file it and check. It's good. I mean,
Right.
that was all too common. But the idea is that we would want to say, hey, you're ISO 9000, you got to do this, you got to do SPC, you got to do that, got to do this. And you send us a certification that you did all this stuff. And then our hands are clean. We don't have to touch it anymore. It doesn't work that way.
No, and culturally too, I think it's what most people forget or don't ever understand is that, yeah, you can convince yourself, and there is a certain logic to it, that if you demand something of a supplier, then they're contractually obligated to you to provide the thing to build to a certain standard, a certain, let's call it build state,
Right.
which encourages reliability and quality. But as soon as you go to option 7, which is what can I do? What sort of arbitrary yes/no test can I do at the point of sale to conclude whether this batch is good or bad? Culturally, within a matter of minutes, your organization will quickly descend into that, again, very transactional organization where there's this constant pressure to drive down purchase prices because that's the only interaction you have with the market.
Mm-hmm.
And so how can you demonstrate, or even to yourself, how can you demonstrate that you're improving your system? How can you demonstrate that you're making things better? Well, the only thing you can address is the price, because you have this arbitrary yes/no test, and everything that comes through that test is as good as anything else that comes through the test. So there's no shades of grey, there's no continual improvement, and you get that very toxic organization where you have that supply team whose one and only job is to gouge the suppliers over and over and over again. And the suppliers will learn how to play the game, because if they don't play the game, they're not going to be a supplier for much longer, and they're going to, whether you like it or not, do things like photocopy X bar R charts from years gone by just to tick the boxes because they're under so much cost pressure to make these half-hearted components, and then everyone loses.
Yeah.
At the other end of the scale, you have those organizations which you and I know about who engage with those suppliers and in many cases are willing to pay more to suppliers if they embed additional features and quality characteristics and reliability into those components, because the business case writes itself. You'll save 3,000 failures later on. Well, 0.5% increase in purchase prices is a no-brainer.
Yeah.
Unless you're in that organization who only deals with option 7.
Yeah. I'm coming back to this, the option where you said, oh, we'll do a statistical test and I was facetious, not really, with the software will fix it, but
Yeah.
it's like, well, we don't understand what statistical testing really is anyway, but we think it's good. So we want to have that happen
Yep.
I think there's some mindset out there that, oh, we'll just draw a sample and then we'll be good. And I've seen this, and it was from a sales engineer, which I knew I shouldn't have been talking to, that said, oh, well, but we run 3 batches and 77 samples of each, and it's according to XYZ set of standards, and we pass it all the time. And I said, okay, let's do a little math here. You're claiming you have a 1 in a million defect rate, and you had, 77, 140, 200 samples. There's no possible way you can support that claim. Right. The chance that you actually have that defect rate with this data set you just presented is a great big leap of faith.
Right.
And so he kind of got red in the face and blustered a whole bunch and says, but it's a statistical test, an industry standard, and blah, blah, blah. And I'm like, all right, great. This test means that you have shown or used this test to demonstrate that you have an 8% defect rate or better. And he goes, well, of course it's better. I said, okay, where's your evidence? So that discussion's quickly spiraled to, let's have lunch.
Right. Well, I mean, the other problem too is customers often demand from suppliers those standards you're referring to. So
Mm-hmm.
suppliers are then forced to comply with industry standard as the customers keep dictating, and then some painful person like you comes around and actually uses
I resemble that remark.
like uses actually math and stats to actually try and scratch layers off. And of course, these salespeople are caught in a catch-22, where everybody else just says, "Yeah, I just want to see you pass a test so I can tell my boss that my job as a supply chain manager is."
We did our job. We did
Yep.
our due diligence. All right. No, and
Right.
and I've worked very closely with some excellent supply chain engineers or supply or whatever they're quasi quality control engineers that did the extra effort to identify the suppliers they could actually talk to,
Yep.
and say, instead of saying, "Oh, here's our standard test, take it or leave it," it's here's what we typically do, what everybody asks for, but here's what we do to make sure it works.
Yeah. Yeah.
Right.
Absolutely.
And instead of just doing the minimum, they were actually doing the process control
Right.
and they were doing process improvement and okay. And it's night and day difference in the products. And they never really worried about the standards testing. It was the condition
Yeah.
of sale and they always passed. But if you start asking the questions of, well, what was the last thing you did that improved your process or improved your yield or improved your product or improved its robustness? And if they had a coherent answer to that, this one guy, he said, I would go back there. I would go out of my way to go back there because it was, you never flew out there to solve a problem or to yell at them because they were causing problems. They took care of it.
Yeah. And they're the ones who actually they're the suppliers who don't put up the shutters when you say, I have a problem.
Yeah.
A supplier that says straight away, oh, it was your usage profile, have the preordained list of
the 5 standard answers.
Right. Yep. For those ones who say, oh, okay, can you please send us the data? Give us as much information as possible. But how is it being used?
Yep.
And I will get back to you at the time frame. They're the sort of suppliers that you go, you know what? Even if they're the most unreliable suppliers, so to speak, at the start of your engagement, they're going to very quickly become your most reliable supplier if they keep responding to.
Let's learn from this and make it better. Yeah.
Right. They're going to quickly become as reliable as you can possibly be. So I suppose that the main point is, what is the main point here? I think it comes down to that confidence thing where we say a lot that confidence is a measure of you, not a measure of your machine or your system.
Yep.
And if you can get confidence from 2 sources: 1, understanding whatever it is that's going on, and 2, from statistics.
And they're not the same thing.
Right. The confidence you get from understanding is a lot more valuable, because all statistics can essentially do is give you some supporting evidence to improve your understanding. But if you already understand your process and your system and your machine, you're already there. I mean, if you already know what the weak points are and when it's going to fail and how it's going to fail, you don't need to do statistics. But the problem with statistics is that you need often an awful lot of it. And in many cases, you actually need to have at least some rudimentary understanding in order to set up your statistical-based test.
Yeah.
It's just that if you don't want to be bothered to understand how the machine, a supplier, is going to provide you fails, then the only option you have left is statistics, which is rarely the best way to go as a tool in isolation.
Yeah, it's not a very good blunt instrument. It's kind of, It's not. And so I think the overall thought here is that it starts when you start picking suppliers, and in the design is, what are you actually looking for? What's the robustness of it? And can you accept a 2 or 3% defect rate for some component? Oftentimes that's a no, very, very often. But then what are you going to do about it? And part of that process is, and this is kind of a summary, is wherever possible is create those relationships with your suppliers for those critical elements of your system that are suspected to have a failure rate that you can't accept, or later you find it is unacceptable, that you can actually work with, that you can trade information. And we used to call it the open kimono. not really sure what that context is, but here's what we know about the science and industry and the technology that we're putting into this component, and what is the data you have, and let's trade information and make this work. That doesn't just happen because you call them with a failure. That doesn't happen at all. And then saying, well, we'll just do a test to compare the different suppliers. There's a lot of that just testing, it goes back to understanding. You got to understand enough about it. I remember one time, this might be the summary statement here, is that it was a manager that oversaw a small internal factory for HP that made mostly just did setups and prototype lines and stuff like that. And his engineering staff worked with the bigger producers like Foxconn and other folks that made circuit boards for us. And he said they were going to shut down the line. One of the cost-cutting things was they're going to shut down this equipment. And his concern is that I won't have people that understand how to make a circuit board anymore overseeing circuit board manufacturers. And just not having that hands-on deep understanding puts us at a disadvantage. And so that was a big issue that he was looking for. And sure enough, in about 4 years, he was exactly right, that he couldn't get staff that actually had the understanding, because the people that wanted to understand electronics would go work for the people making electronics. And so he ran into that.
So it sounds like pretty much every governmental and military customer we know right now.
Yeah, pretty much, yeah. Although there are some really, really smart people out there, but they're kind of shouted down by the bean counters and contractors and everybody else. So.
Well, being smart doesn't necessarily mean that you're able to, manage your suppliers.
Oh, no. And usually the smart people that actually knew the technology and the material science and all that other stuff were kept away from anything dealing with suppliers.
Right, that's true, actually. You see how you might have a thruster who was once a CO of an armoured battalion or a tank regiment, didn't quite make it for the brigade commander list, and all of a sudden now they're a project manager for the next great bit of engineering magnificence in said military, and they don't know that they don't know.
Yeah,
they just think that I'll just use my extant military magnificence to solve any problem that's in front of me. It just doesn't work like that.
No. Yeah, physics and gravity doesn't really care.
Right.
It's going to deal with it. All right. Well, anyway, we rambled on a good bit on this one, but the idea is that you do need some understanding before you open the stats book. Not just about statistics. You might be a brilliant statistician, but it's just not going to solve every problem without some basic understanding of what are you looking for, or what are you trying to do. If you've got a thought on this, and if you know of it, we touched on a handful of disaster stories, or you've run into this circumstance before, let us know. Head over to ascendoreliability.com/go/SOR, and you can leave us a message. You can find Chris and I and the other hosts of the show on LinkedIn or on our About pages. And as you know, we always enjoy hearing from you and getting those questions and ideas for upcoming podcasts, and we look forward to hearing from you soon. So I'm just thinking there's probably 15 more episodes in this discussion, but we better wrap it up here pretty quick, Chris.
Absolutely.
All right. Well, we'll talk to you again soon, Chris. Take care.
See you next time, Fred.
Thanks for listening to Speaking of Reliability. We invite you to join the conversation. If you have a question or a topic that you think we should discuss in a future show, please let us know. You can find a comment box below the episode show notes, or just leave a note as part of a review on iTunes.